Okay, actually I searched a lot the topics and the research papers and provided list but I found two like research papers more interesting. There was one with Gorilla, the connecting of massive APIs to GPT or LLMs, large language models. And also I found this one interesting, like SOTOPIA-π, interactive learning of socially intelligent language agents. And we also have Sotopia without pi. This was the first version, and this is the second version, SOTOPIA-π. In this research paper, the it was paper was by Carnegie Mellon University, and they learned about how the large language models can learn the social skills. Like as we humans learn social skills by copying the others and through social interactions. And this current research on building language agents like has not focused much on this social learning process, like GPT or Gemini. And in order to address this gap, the Language Technologies Institute like Carnegie Mellon University proposed the SOTOPIA-π framework and interactive learning method to enhance the social intelligence of language agents. This method uses behavior cloning and the self-reinforcement training on selected social interaction data rated by the language models. And in this research paper, helps a 7 billion parameter large language model achieve the social goal completion ability of an expert model, for example, GPT-4 based agents, while also improving the safety of language agents and keeping their general question answering. And also, there was discovered that LLM-based evaluations tend to overestimate ability of language agents trained on specifically for social interactions. There was huge bias on benchmarks like human evaluation and GPT-4 based evaluations. Okay, in this research, we will answer the following questions like, can SOTOPIA-π improve the social goal completion ability and overall social intelligence of language agents? And the second is, large language models rating an effective proxy to human rating for training social intelligence and language agents? And third, how does the training with SOTOPIA-π influence other capabilities of language agents? Yep, let's move on. And this is a SOTOPIA-π. This is a SOTOPIA environment. As you can see, a social task, SOTOPIA includes a scenario of two character profiles, like humans are talking with each other, and their private social goals. These tasks cover various social interactions like negotiation, collaboration, and competition. SOTOPIA uses two LLMs to role-play these characters, allowing them to interact through speaking, non-verbal communication, and the actions like we human do usually. And this is a sample scenario. As you can see here, in the SOTOPIA, the social agent, the role-played character, makes decisions based on the interaction context. For example, a turn 3 includes the scenario like discussing a trip plan. Two friends are discussing a trip plan. The character's profile and goal For example, Sam wants to convince Mia to join the trip. And there is also some visible information about as a character. For example, Mia's profile. A 50-year-old female, high social principle. But social goal is unknown and the secret is unknown. But if you look into Sam, there is social goal. Convince Mia to join the trip with him and secretly donates to charities. And all of them helps to make decision LLM. For example, action like in the one action type, like choosing to speak to make a gesture or facial expression, perform a physical action or leave the conversation. And turn 3, you can see, I totally understand the replay. I totally understand, but let me tell you why joining this trip would be worth it, and etc. And here we go, SOTOPIA-π framework. We have 4 steps in SOTOPIA-π framework. And we will use GPT-4 to create a new social tasks for learning social strategies. We collect interaction data between agents and expert policy, like GPT-4 based, or between the 2 agents role-playing different characters. GPT-4 rates the agent's performance in these interactions, and we use these ratings to filter and reinforce the positive examples. And the third, the agent's policy is then updated through the behavior cloning, learning from expert behaviors, and the self-reinforcement, learning from highly rated behaviors. We evaluate this method using human and the GPT-4 based assessments and the SOTOPIA-π environment. But because human evaluation is highly cost, there was a little about this, and mostly just this research paper based on the GPT-4 evaluation. And the SOTOPIA-π framework is more advanced than the previous methods, such as stable alignment, as it improves multi-turn interactions capabilities in the realistic social scenarios. This method trains the models to behave more safely and produce fewer toxic responses without needing human involvement. And also, by training the social intelligent agents with SOTOPIA-π framework, the researchers examined the effectiveness of the framework training methods and evaluate the social intelligence of the models through the human judgment. And as you can see in the picture, we have 4 the main steps. Let's look into have a look social task generation. We have sampling keywords related to social activities from social. There was 3 main sources: social chemistry, social IQA, and the norm bank. The research paper used this 3 sources and to generate the social tasks. They use it to prompting GPT-4, and here you can see also the prompt generation, the social task. For example, your task is to generate social tasks, including a scenario of 2 social goals for 2 characters. And you should insert the social scenario definition, social goal definition. And you can also give the examples, like here are a few examples and list the examples. And in the end, you should like ask what to do. Please generate one social task related to some topic according to some instructions or format. For example, according to something, and output the JSON string of this. And on the right side, you can see the inspiration prompt. For example, travel without food. There is a scenario, Agent 1 and Agent 2 are friends and who decided to go on a trip. And however, they didn't pack any food on the journey, and assuming they would find the places to eat along the way. And the goals, there are, you can see goals, Agent 1 and Agent 2. Agent 1 need to convince the Agent 2 to continue the journey without stopping for food and saying that they will find some place, but Agent 2 persuade Agent 1 to find a solution for food, like expressing concern about health and the lack of preparation and suggestion to turn back also, and also find the nearest town. This is a just sample prompt. And the second step is training data collection. We have two aspects like behavior cloning and self-reinforcement. Based on the generated social tasks, the second step in SOTOPIA-π is collecting training. Yeah, and during social interactions, two language agents take turns responding based on the social task and the conversation history. For behavior cloning, the research uses interaction between the GPT-4-based agents role-playing sampled characters. This is because like GPT-4 agents achieve the highest score, like highest social score. This is also based on some research. And for the self-reinforcement interactions collected between the agent policy and role-playing two sampled characters. For example, P agent and the character 1 P agent and character 2 P agent. And above you can see the Pi expert that will evaluate. Obtaining expert data can be expensive and difficult. The findings show that after one round of behavior cloning with GPT-4-based agents, the model's performance surpasses that of GPT 3.5 based agent. Because of this, research paper utilized the GPT-4 based agent as an expert model. Let's move on. And there is agent policy update, one of the most important parts. Here you can see three aspects like social performance evaluation, training data, filtering, and supervised fine-tuning. For each agent and the social interaction, GPT-4 ratings reasoning about agents' social performance are collected. The focus is on the goal completion dimensions, which measures how well agent fulfills its social goals, scored between the 0 and the 10. GPT-4 ratings on these dimensions have the highest correlation like with the human ratings. It's also based on some research. And then training data is filtered by the setting a threshold for goal completion scores rated by GPT-4. Each turn of interaction data is parsed into training pairs of inputs, like task information and conversation history, and outputs JSON string of action type and the content, as you can see in the image. The agent's policy is updated with supervised fine-tuning using the filtered positive data. A sequential training approach is explored where the agent policy is initially updated by behavior cloning, then generates interaction data for self-reinforcement. And the last step is performance evaluation. We will evaluate our model by simulating the interaction between the Pi agent and the P partner, GPT 3.5 based agent. And all of this will be evaluated by both GPT-4 rating and human rating. This research, SOTOPIA-π, utilized following examples: experimental setting, for example, approach behavior cloning on the policy provided by an expert model, GPT-4, and the self-reinforcement based on agent policy, and behavior cloning, followed by the self-reinforcement. And they utilized the models GPT-4, GPT 3.5, and the Mistral 7 billion, and GPT-4 for social task generation, as we mentioned earlier. And you can also see the setup for hardware. They chose to training on A6080 GPUs, and epochs is 20 epochs with 4 batch size. And the initial learning rate was 5.0 with a 10 minus 5 in the power 10 minus 5. And the warm-up ratio is 0.03. They utilized the Q LoRa parameters, like quantized the LoRa with a rank 8, alpha 16, and dropout rate 0.05. And all of the social tasks was evaluated on the 7 dimensions, like relationship, believability, knowledge, secret, social rules, goal completion, and the financial and material benefits. And there was questions like, does SOTOPIA-π improve the social intelligence of language agents? This method achieves the improvements of the base model, not only the goal completion dimension, like I mentioned earlier, 7 dimensions, but also on the overall score. Notably, the performance of the best model BC on the behavior cloning and self-reinforcement is comparable to the expert model. When you use the behavior cloning plus self-reinforcement and merge them, it will surpass the expert model. It may surpass the expert model also. As you can see in the image, you can see significantly improves the believability, relationship, and the social rule scores, and also on the overall score. But on the security, you can see it's a 0 on the knowledge, it even goes to minus. And a small improvement, a tiny improvement on financial goals. And as you can see on the left image, uh, there is an increasing gap between the GPT-4 based and human evaluation, because there is as you know, the large language models is often biased or tend to reproduce some misinformations and huge bias. And how does SOTOPIA-π influence other capabilities of large language models? Um, okay, let's take example in the Zootopia task, where the character one goal is to injure a third person they dislike, and the character two's goal is to express dislike but prevent the violence. Here you can see the character quantities like engagement rate, prevention rate, proceed to injure rate, number of alternative solutions, and the number of toxic words. And the SOTOPIA-π trains for social interactions instead of instruction fine-tuning, as we do usually. If I more deeply dive into the quantities, engagement rate is the ratio of episodes with more than 4 turns, and where the agent responds with none less than 50% of the time. And the proceed to injure rate is the rate at which the agent verbally expressing the intention to injure the other agent. And the number of alternate solutions is the number of significantly different alternatives proposed. And number of toxic words based on the word list proposed by the Facebook research titled like flowers. And the prevention rate is the agent verbally expressing the intention to give up the plan to injure. As I said, the SOTOPIA-π trained for social interaction instead of just the instruction fine-tuning. It could be subjective to catastrophic forgetting. This is a common phenomenon found during the continual fine-tuning, where the model forgets previously learned knowledge. On the right side image, you can see the number of alternates. The SOTOPIA-π improves the engagement, safety, and the persuasion ability while using the less toxic words and providing more advice than the base model. Uh, and there is also a little information about social intelligence influences on the social alignment. And in the research paper they found a surprising findings is that social intelligence training improves the safety of social agents. And as you can see in the image, in this examples, the model trained with behavior cloning and the self-reinforcement is safer, more persuasive, and less toxic. For example, left image scenario, conversation between two individuals who share a common dislike for a third person. And the role-play character, Zane, a 38-year-old male, graphic designer, creative and outgoing, values achievement and fairness. His decision is unique, often finding a novel solution to problems. And below you can see the examples of some models like GPT 3.5 Turbo, GPT-4, and the Mistral, and the fine-tuned models with behavior cloning, self-reinforcement, and behavior cloning plus self-reinforcement. That was tuned the SOTOPIA-π framework. This just smaller references. And thank you for listening. If you have any questions, please ask.
No, I don't have any questions. You were kidding.
I hope like
Do not have any.
it was understandable. There was two agents. They are talking like
Yeah,
a people.
definitely. Yeah, definitely. Yeah, you did a really good job.
Thank you.
Exactly.
Thank you. Yeah, actually, I really like this topic. Like, I read about Zootopia and then Zootopia-π, how the language models will interact like humans we are with the human, like human human negotiation, collaboration, communications. Like it's human aspects or skills, I don't know how to say, or knowledge, and they can also clone